In this video, we will use the IReS platform to plan and execute a web analytics workflow. The workflow reads an initial set of crawled web pages from HDFS, trains a word-to-vector model, and uses this model to vectorize newly crawled web pages. The extracted vectors are used to train a classifier that classifies the web documents into categories. You can hover over each dataset and operator to see its respective metadata. For an initial dataset of 30,000 documents and the objective of minimizing the execution time, we invoke the IReS Optimizer and Planner by clicking on the Materialize Workflow button. Given that we have both a centralized and a distributed implementation for each operator in Python and in Spark respectively, this is the graph of all alternative execution plans. IReS, based on execution time estimation, chooses the one that consists of Spark implementations for all operators to fulfill the given policy. The estimated total execution time for the workflow is about 113 seconds. If the policy is set to minimize the cost, that is, the use of resources, IReS will choose a plan with centralized implementations for all workflow operators. If we decrease the input size to 2,000 documents, maintaining the policy of minimizing the cost, IReS again materializes the workflow, choosing the centralized implementations. For the small dataset and a policy of minimizing the execution time, IReS picks the centralized implementations, in contrast to the case of the big dataset. This choice is again based on the execution time estimations of each operator. When we press Execute Workflow, yarn containers are allocated and the first operator, word-to-vec training, starts its execution. Its status is set to running. We confirm that indeed one of the nodes of the cluster has been allocated. When the operator finishes, the node becomes green and results are stored in HDFS. Now the training of the classifier is taking place. After the training of the classifier completes, the model is also stored in HDFS. The whole workflow stops running as soon as the last operator, classifier, concludes. When executing the plan that contains the Spark implementations of all operators, the respective resources calculated by IReS are allocated for each running operator. 11 cores for the word-to-vec training operator, 36 cores for the vectorization operator, 36 cores for the training of the logistic regression classifier, and 36 for the classification operator. Results are materialized in HDFS and can be browsed.